Hello students, welcome back to Geographical Investigation series, Data Gathering Methods for Coastal GI. So in this last part of the methods series for this Coastal GI, we'll be going through observing travel patterns of floating objects, which will be used in order to determine direction of sediment transport and subsequently make certain conclusions about longshore drift. I hope you remember what that is. So without further ado, this is what we'll be covering today. As per the other videos, 3 questions that will help guide your thinking with regards to this method over here. When do I use this method? How can I carry it out? What do I need to consider when carrying out this method? Alright, so let me just recap with you your longshore drift and sediment transport on coasts, because I think many students confuse themselves when it comes to this. Alright, let me pull this diagram up for you. So basically these are the main forces of transport or processes that happen on the beach. So as you guys have learned in your lessons, prevailing winds results in waves approaching the coast at an angle. So over here you see the wave direction. So the wave direction, the wave is moving this way because of the prevailing winds. And this causes sediments to be transported on the beach by the swash. So this upwards movement that you see here is the swash. Alright, so then what happens is that, remember the saying, what goes up must come down, right? Because of gravity. So as the swash washes sediments up, or as the water goes up the beach and deposits certain sediments up via the swash, gravity then pulls this water back down at the right angle, resulting in a backwash. So you see some sediments being pulled back into the sea. Okay, so I hope that explains to you your swash and backwash, and I hope you remember what is causing the swash and what causes the backwash. And this results in a zigzag motion in terms of sediment transport. Alright, so in terms of processes, the zigzag movement, as you see here, sediments moving from this way to this way, is known as beach drift. So just know that this is beach drift over here. Okay, so when waves approach coast at an angle, so for example, you have your seabed, right? So you have your seabed before the waves actually break onto the coast. How deep the seabed is near to the coast may actually cause the waves to crash earlier. So as you know, these waves actually have a lot of kinetic energy to them, right? So as they crash onto the shore, they release bursts of energy. So and this burst of energy that is released along here results in a longshore current, and the longshore current runs parallel to the shoreline. So the longshore current can also carry sediments. So what I need you to understand is that what we have here is not a single process. However, the sediments that are moved via beach drift and the sediments that are moved via the longshore current result in this bigger thing that you guys know as longshore drift. So make sure that you understand what is going on here when we're talking about sediment transport. Okay, so one thing that I need to bring to your attention is that sediment movement is thus influenced by wind direction because the wind drives waves. Okay, so wind direction affects the sediment movement because sediment movement is caused by the waves, right? So there is a relationship here, and you might want to explore this for your geographical investigation. Alright, so the first question that we'll be tackling is, when do I use this method? So basically, you should carry out this method when you are interested in uncovering the direction of sediment transport influenced by the longshore drift. Okay, so if you want to know where sediments are, which direction sediments are moving in, you would want to use this method that we're going to go through. Some of you are wondering again, why is this so important? Why do I actually even need to know this information and waste my brain space? So, when you know the direction in which the sediments travel, or you know the direction of sediment transport, you can actually then plan where to place intervention measures. So for example, your groins, right? Your groins cost thousands of dollars to build. If you haphazardly or anyhow put these groins anywhere, right, you are wasting money, because you may actually be placing them in a direction where sediment does not travel, or putting them in the wrong places. And this actually results in wasted time, effort, and resources, which you do not want to do. Alright, so how can I carry it out? Basically, you will need these items that I've listed out over here. You need a ball attached to a string. Please make sure that your ball can float. I would not advise you to use balls that can sink, because this would beat the purpose. So a tennis ball is actually a very good ball to use because it floats on water. Secondly, you need a stopwatch. Third, you need a measuring tape. And lastly, you need 2 ranging poles. So you see how ranging poles are very, very important to coastal GIs, because they allow us to carry out our different methods. So now let me explain to you how you will actually do this method step by step. So step 1, I need you to find a safe spot where your view of the open ocean is not blocked. And then you will use a wind vane to find the direction of the wind. So I assume that all of you know how to use a wind vane, and that you know how to align it to the compass. Okay, so you cannot get this step wrong. Secondly, near the water's edge, stick the first pole in the sand. So this is basically where you're going to start your measurement. Wherever you're going to start your measurement, you poke that ranging pole into the sand. Okay, then the next step, what you need to do is you need to have the string and ball ready, and then I need you to throw it at least a meter away from the water's edge. Alright, so as you throw the ball and the ball is floating on the sea, what you will actually realize that the ball is being moved from one location to another, right? So this is akin to what sediments actually experience as a result of this sediment transport process. So what you need to do is you need to observe the path of travel of the ball for at least 10 minutes. So it cannot be 5 minutes, cannot be 2 minutes, that's too short. I need at least 10 minutes for you to observe where the ball is going. So one thing that I need you to also remember is that please make sure that your string is long enough. Okay, so therefore make sure there is extra string for the ball to actually be carried by the waves, by the currents, so that you will have an accurate recording of where the direction is at. Alright, so you see the ball moving, right? So in when you guys do your coastal GI, you will see something like this. Alright, so after you've waited 10 minutes and you've observed, and then you see that there's the ball has finally went somewhere. So track down where it goes after 10 minutes, and then wherever it is being washed to, or wherever it is, for example, is already on the beach, what you need to do is you need to stick the second pole. So the first pole is to record where it started. The second pole is to record where it actually ended up after 10 minutes, after being moved by the series of swash and backwash. And then after that, use a measuring tape and measure the distance between the 2 poles. Okay, so by doing this, you can actually observe where is the direction of sediment transport, or how far the sediments actually travel. So 2 things you can actually ascertain through this method: which direction, how far. So second pole and first pole, the distance actually tells you this information. So simple as that. By doing that, you can actually identify the direction of sediment transport, as well as the influence of longshore drift on sediment transport. So now you have been equipped with knowledge on how to study sediment transport. Let us now look at the important considerations. Basically, when using a wind vane, when you are using a wind vane to identify the wind direction, the north of the wind vane must be aligned with the compass north. So you need to make sure that the north that your wind vane is pointing to is actually the north on the map. It needs to be aligned with the compass north, okay? So if you fail to do this, you will have an incorrect identification of wind direction. Let me show you what I mean. So in red here, This is the compass direction. We see that north is pointed this way. However, I anyhow go and align my wind vane, and then north is actually pointing to here. So let's say my wind direction is blowing from the east over here. My wind vane would actually track it as north. So over here, and then you will actually have a very, very inaccurate reading, and then that will affect the accuracy of your data. So please make sure that you do this step properly so that you don't have to go and redo and waste your effort. Alright, so now before I say goodbye, because this is the final part of the video, right? I have some final words. So let me just pull up this overview. So you guys are now masters of these 4 different methods. We will not be going through this last one today. You are basically masters of these 4 methods, and you guys should be able to list down, describe to me how to do it, explain to me how to do it, as well as tell me what are the considerations that you need to keep in mind when you guys are doing this. Okay, so some closing remarks. In gathering data, you need to first be sure of what you need to gather. For you to be sure of what you need to gather, you need to be sure of your hypothesis first. You need to know what variables you're trying to study. Secondly, whether your chosen data gathering method captures the data that you need. Okay, so you need to, if I want to find something about sediment transport, do I actually use wave frequency? We don't use wave frequency, right? Because wave frequency just tells us the type of waves. It doesn't tell us about direction of transport. It doesn't tell us anything about sediment transport actually. Okay, so that is very important, this point here, whether your chosen data gathering method captures the data that you need. Okay, one word of advice that I can give you, if you want to practice, try coming up with different hypothesis statements and then try to identify the data that you need to gather. After you have done that, see if you can identify the correct method to gather data that you need. If you are able to do all these 3 steps easily, I would say that you kind of get the idea of what I'm trying to say in this first part over here. Alright, so before I say goodbye, just to close up the whole series, in this lesson we have explored the following methods: the beach profile and gradient analysis. We have went through the methods of how to do sediment analysis. We have went through the methods of how to do wave frequency analysis. And lastly, we just covered how to study sediment transport and how to analyze sediment transport and the methods that we use to do so. So remember, each of these methods can be used to gather data about different aspects of coastal environments, and you need to be sure of what methods you use, whether your methods are correct, before you head down to your GI site, so that you do not waste time fumbling through the equipments. Okay, so that is all I have to you. I hope this series of videos have been helpful in clearing your doubts with regards to coastal GI methods. Remember to like, share, subscribe to your friends who you think may need this geography content, and I'll see you in the next one. Thank you for tuning in.